In this video, I'm going to explain what is Docker, its differences with respect to virtual machines, and we will learn how to build the Docker image of an easy Python program. Prerequisite for this video is to have installed on your laptop, Python and Docker. For the Docker installation, you will find in the video description the links for the Linux and Windows installation guides. Docker is an open platform, written in the Go programming language, that allows you to package and run an application in a loosely isolated environment called a container. It, therefore, facilitates shipping and developing of applications. Docker uses a client-server architecture. The Docker client talks to the Docker daemon, which builds, runs, and distributes your Docker containers. The Docker client and daemon can run on the same system, or you can connect a Docker client to a remote Docker daemon. The Docker client and daemon communicate using a REST API, over Unix sockets or a network interface. A Docker registry stores Docker images. You can use public registries or run your own private registry. Let's now see which are the main Docker objects. An image is a read-only template with instructions for creating a Docker container. Creating a Docker image is really simple. For that you need to create a Docker file. There you will define the steps that are needed to create the image. Each instruction generates a Docker layer in the image. Every time you modify the Docker file and you rebuild the image, only those layers which have changed are rebuilt. This allows Docker to be very fast and light. A container is a runnable instance of an image. You can create, start, stop, move, or delete a container using the Docker API or CLI. Let's now see which are the differences with respect to virtual machine. Both technologies are used for isolating and managing applications, but they have some key differences. From the architectural point of view, virtual machines, VMs, emulate an entire operating system, OS, and run on top of a hypervisor. Each VM includes its own OS, kernel, and separate resources. Docker uses containerization to package applications and their dependencies into a single unit called a container. Containers share the host OS kernel but are isolated from each other. In terms of resource efficiency, VMs are relatively resource-intensive as each VM needs its own OS and memory allocation. Containers are more lightweight and efficient, as they share the host OS kernel and only require the resources needed by the application. For the startup time, VMs generally have longer startup time since they involve booting an entire OS. On the other side, containers can start up very quickly since they don't require booting a separate OS. Portability is also another key difference. VMs can be less portable because they often rely on specific hypervisors and hardware configurations. Containers are highly portable since they encapsulate applications and dependencies, making them easier to move between different environments. Possible use cases of these technologies are: VMs are well suited for running multiple different operating systems on a single physical machine, such as in server virtualization scenarios. Docker is great for packaging applications and microservices in a consistent and reproducible way, making it ideal for application deployment and scaling. After this first introduction about Docker, let's now see how to build a Docker image of a very simple Python application. We will build a simple Python program that calculates the square root of a number and displays the result. The number can be passed by the user. Let's first of all create a Python file with our program. Our program expects to receive one input number by the user. For that, we have a check on the input length. If it is different from 2, it returns a message with the app usage. The length is 2 because the Python script name itself is the first argument, while the second argument is the input number inserted by the user. It then calculates the square root and check for the validity of the input. For this script, we need to install the NumPy library. For that operation, we could also use the math library that comes by default with Python, but the purpose is to show how to install other libraries in the Docker image. Once it is installed, we have to create a requirements.txt. This is a file that lists the dependency of our Python environment. You can automatically generate it with the command pip freeze requirements.txt. We have to create now a Docker file that will list the operations to create the Docker image containing our program. I've already created this file. Let's analyze line by line. The first line from Python 3.10 tells us to use the official Python image as the base image. But we need to set the working directory in the container. We copy the Python application files to the container's working directory. We install required dependencies. For that we need to copy the dependencies from the requirements.txt file to a destination file. In this case it has the same name. We finally install the dependency in the container. Finally, the cmd instruction is used to specify the default command to run when a Docker container based on this image is started. When you start a container from an image with this cmd instruction, Docker will automatically run the python app.py command inside the container. This is typically used for running the main application or process that the container image is designed for. Before building our image we will need to start the Docker daemon. On Windows, to start the Docker daemon you need to launch Docker Desktop. This is an application that allows you to manage containers. In Linux, you typically do not need to start the Docker daemon manually in the same way as you do in Windows. Docker is designed to run natively on Linux, and it starts automatically as a system service during system boot. Let's now build our image. We can build the image with the command docker build my_python_app. Let's break down it. Docker build, this is the Docker command for building Docker images. my_python_app, this part of the command specifies the name and optionally a tag for the Docker image that you are building. In this case, the name of the image is my_python_app, and there's no specific tag specified, so it will use the default latest tag. The T flag stands for tag. The period, dot, at the end of the command is the build context. It tells Docker where to find the Docker file and any other files that may be needed during the image building process. In this case, it's telling Docker to look in the current directory for the Docker file. So, when you run this command, Docker will look in the current directory for a Docker file, named Dockerfile by default unless specified otherwise, and it will use that Docker file as the blueprint to build a Docker image with the name my_python_app. This image will be based on the instructions and files defined in the Docker file. Let's proceed to build the image. Once the build is completed, you can use the my_python_app image to create and run Docker containers. To run the Docker container we can use the run command. Docker run my_python_app python app.py5. Let's analyze it. Docker run, this is the Docker command used to run a Docker container based on an image. My_python_app, this is the name of the Docker image from which you want to create and run a container. Python app.py5, this part of the command is the command that you want to execute inside the Docker container. It's specifying the following. Python, this is the name of the command you want to run inside the container. In this case, it's the Python interpreter. app.py, it specifies the name of the Python script you want to run. So, it's telling Python to execute the app.py script. 5. This is an additional argument being passed to the app.py script. In this case our script looks for an input argument and calculate its square root. Let's execute the command and observe the output. We have completed this mini tutorial about Docker. If you've enjoyed this video, do not forget to subscribe to this channel.